Welcome to the Driving the World podcast series. I'm your host, Cully Holland. Today we have Jeremy McCullough, a senior product engineer, and we're continuing our conversation on power and energy solutions with regenerative energy. Hey, Jeremy, really appreciate you spending so much time with us on this power and energy solutions. How are you doing today?
I'm good. How are you?
Doing great. So I've been hearing about regenerative energy, and maybe that's something SEW does, but let's start off and maybe just discuss what regenerative energy is, and then we'll talk about some solutions SEW may have. So what is it?
Sure. So I guess when most people think of a motor, right, it's something that you have to power it, and it consumes energy because it's moving something. However, there are cases when a motor can act like a generator, basically. And without getting too much into that, but some examples would be like, let's say that you have something moving along at a constant speed and the motor's moving it, and then it has to slow it down. What happens is you have all of this kind of energy in whatever moving system you have, and you have to somehow get rid of that. Like you have to take it away. And so the motor, in essence, kind of becomes a generator, basically. And the energy flow ends up being outward instead of energy flowing to the motor. Energy is flowing from the motor back into whatever's supplying it. Now, for an electrical grid, that's not a problem, but for a VFD, and for reasons that we're not going to get too in depth into, but most VFDs, like the simple VFDs, like the common ones you see, they're kind of a one-way street. You can put energy into them, but because of their design, they can't send energy back to the grid. And so what happens is you have a motor that's decelerating. Another example would be like a lift that's going downward, and you don't want it to free fall. You have to kind of, slow it down so that it's not, plummeting. That's also where it's acting like, a generator, and it sends energy back. And so what happens is that energy gets back to the VFD, and there's nowhere for it to go. And so what happens is, something called a DC link voltage, which is the voltage it uses to kind of synthesize the AC output, it starts to rise. And at a certain point, this gets to a level where it's harmful to the VFD and to the motor and to the cabling and all the components and things. And so you have to do something with that. And the traditional approach is to use something called a braking resistor. And if you're familiar with VFDs, and you probably heard this term before, and if you walk around a plant with a bunch of electrical cabinets and things with VFDs inside, then you may have seen them on the top. There's these grid-shaped things with a touch guard, and they sit on the top or back of panels. And basically what they are, they're heaters, essentially. That's all they are. They're heaters. So they basically take that excess energy and they put it off as heat, which that's a very simple solution. It's a very proven solution, still common industry practice just because it's simple. But when you think about that, okay, it's going off as heat. If you had a space heater just kind of plugged in the middle of your plant, just going, especially in an air condition, in the summer, you would see that and be like, why are we heating, the plant? And so if it seems like it's inefficient to do that, it's because it kind of is, right? It's just it's a convenience factor. This is the easiest way to get rid of it. And so some customers are kind of clued into that. They understand that, if they have a lot of regenerative energy, it's going off into heat, which that's just wasted energy to begin with. But also, if you think about how if you have an air-conditioned plant or even like a freezer or something like that, if heat goes into that, you have to pay to remove that heat. So, it's a compounding problem. And so it's become more of a focus, I guess, maybe in the last 10, 20 years. Hey, are there any other solutions for dealing with this regenerative energy other than just burning it off as heat?
Right. So we were talking about optimizing solutions, and just burning energy off as heat does not sound that optimized. And you're saying past 10, 20 years, we're thinking, what else can we do? And that leads me to believe that we have found a solution, or at least another option. So how is SEW handling this regenerative energy and making it useful instead of just heating an air-conditioned plant?
Sure. So, and it's not just SEW, this is kind of a universal problem, and any VFD manufacturer will be kind of familiar with this. But, we're starting to see more and more regenerative units. And what a regenerative unit is, whenever I talked about a VFD being kind of a one-way street, energy can come in, it can't go out. Regenerative supplies, VFDs, they can go both ways. So they can pull energy in, and they can also send it back to the grid. which is great. However, there's a few drawbacks to that. One is typically because the VFDs and the way they're designed, they can introduce kind of some noise or interference, like the energy that they send back in, the voltage and all that stuff gets distorted a little bit and can cause problems for other equipment. So there's some special sizing and things you have to do. Maybe there's extra filters. Regenerative units are, if you haven't guessed already, it's more expensive than a standard unit.
One would guess.
So you would have to make it, make sure it makes sense. And of course, SEW has been actually offering regenerative units for a long time. So that's one way of dealing with that. And we talked about the stacker crane or automated storage retrieval system in the last podcast. That would be an example where a regenerative unit could make sense because you have a gigantic, crane that's maybe going, it's taking a pallet from 100 feet up in the air and it's bringing it down to ground level. There's a lot of regenerative energy associated with that. And if you can put that back into the grid rather than putting off as heat, then that's better. Another thing is, especially in freezers, like storage retrieval systems are popular in freezers because, that's a difficult working environment. And if you can have a machine go in there and get, your pallet of ice cream, you don't have to put somebody through all of the, stress of having to go and drive a forklift in there. Some places still do it, but, storage retrieval systems are popular in that regard. But in that case, if you had a braking resistor, then that's bad because, you're heating up your freezer. It makes no sense. So regenerative supplies, they can make sense for a lot of applications. There are some smaller applications like, simple conveyors where it makes less sense. Or, you kind of have to think in terms of like, what makes sense for this application? Because if it's only decelerating like once a day or once an hour, then it, you may not get the payoff from going to a regenerative unit. But that's one way of dealing with regenerative energy is to send it back to the grid.
Okay. And like you said, we were talking about in our last podcast, we need the application information. What are you trying to do? How are we moving? And that'll let us know if we even need to talk about regenerative energy. So we're sending it back to the grid. Maybe we can track that. Maybe we get a kickback from the power company. Who knows? Is there something else we can do with this power? So we can either send it into a braking resistor and create heat. We can send it back to the grid. Do we have a third option of how we can utilize this energy that's being generated by our motor?
I would say we have a third and even fourth option.
Okay.
So the third option, if you think about that, storage retrieval system, and again, the analogy I gave is, the vending machine with the soda bottles inside of it. When you look at that, like whenever it picks up the bottle and it's bringing it down to where you would pick it up, if it's coming from like all the way at the top on the far side, notice as it goes down, it's moving over. So it's not just, doing one movement after. It's not moving down and then over. It's normally kind of going in a diagonal. What you can do is if you link two or more VFDs together, if you have one motor or one axis that's in regenerative mode and it's sending energy back, as long as you have energy being consumed by another motor, like let's say that it's moving the travel along the axis, then you don't have to worry about where you're sending it. You don't have to send it back to a brake resistor. You don't have to send it back to the grid because something else is using it. And so basically you're just rerouting that. And so we make, along with many other manufacturers, we make a modular form factor VFD where you basically link all of the axis modules together. And if you optimize the travel profiles, we actually have software modules for that as well to optimize these travel profiles. Then, while you're moving down, you can use that energy to power a different movement that you happen to need at the same time.
I mean, that sounds amazing to me. I'm creating energy and I need energy. So why send it anywhere else rather than where I need it? So that's a great third option. And you mentioned a fourth. So what is our fourth option?
So the fourth option is to use some sort of intermediate, energy storage. Because if you have a high cycling application, has regen or, otherwise, like chances are like you could burn up that energy, you could send it out, but if you couldn't do anything else with it, like if you held on to it, you would probably use that up on the next cycle. So, you don't necessarily have to send it off as heat. You don't necessarily, maybe you don't have a movement that you could use up that energy, with another motor. And maybe you don't want to send it back to the grid because you're just going to pull it right back, again later, and you have to deal with all of the downsides associated with that. And so what you can do is use, energy storage like capacitors and things like that. So it basically just kind of goes into a buffer. If you think kind of like a big battery bank, it just goes into that. It stays local to that, machine. And then the next time it needs to use that energy, it just pulls it right back out again.
I mean, those last two options sound fantastic, especially when it comes to optimizing the energy that you've already used and now you're generating. So you're talking about smart system sizing, talking about efficiencies. Those last two really sound like the best options we have. But of course, as you mentioned, you have to have an application that is warranting the extra costs of either the capacitor or the VFDs that can do this power sharing, is what it sounds like to me. And they're not just, creating generators for 1 second out of an hour. So as long as our customers are talking to us and we size it, we can optimize it. If the solution or the application calls for it, it really sounds like those last two options are fantastic for regenerative energy.
Yeah, regenerative energy, also things like peak reduction, like, if you have a capacitor bank, you can use it for like power backup, like, if your power blips off, well, you have this battery bank or, capacitor bank that you were using to absorb regen. Well, that is storing some energy that you could use for other things and other purposes. And it's a whole big topic, but there's a lot of different ways we can approach things, but that's kind of, why we encourage customers to come and talk to us about our applications, because we can figure out what makes the most sense. Because, some applications, it makes sense to make them simple, but in others, you can get payoffs by going with, a new technology or, something else out of our portfolio. And the way I look at it is, SEW, we have a whole set of, tools that we can use to achieve, a certain outcome. And it looks different, for every different case, but we can figure out what is going to be the best option for any given, scenario.
Well, I'm hearing it's going to be application dependent. We have a lot of great options of how we can utilize and optimize, especially this regenerative energy. And we're really just hoping our customers reach out, talk to us, describe their application so that we can really give them the complete solution that's going to fit their needs. Is there anything else on regenerative energy that we want to discuss, or was that a good 10,000 foot view with 4 options of what do we do with extra power?
No, I think that's a good, overview in the basics. There's a lot more. It can be a really big topic, but that's kind of just the basics to understand. Like, it kind of forms the motivation for, whether or not you would consider a solution like this.
Well, if we piqued anyone's curiosity, please feel free to reach out. And Jeremy, as always, we appreciate the time.
Of course. Thank you.